Right now, hundreds of thousands of people across the Midwest are waking up without power, cutting downed trees off their roofs and pulling standing water out of their basements, because yesterday, a wall of wind that met the official definition of a derecho tore a path more than 600 miles long from Iowa all the way into Ohio. Gusts topped 100 miles an hour in spots. At least 3 people are dead. And here's the part that should genuinely concern you if you live anywhere east of the Rockies right now, because forecasters are already warning that this isn't over. The same volatile pattern that produced yesterday's damage is expected to keep firing off round after round of severe thunderstorms across a huge stretch of the country over the next several days, with the flood threat in some areas becoming just as dangerous as the wind. Today, we're breaking down exactly what happened across the Midwest, what a derecho actually is, and why it's capable of producing damage that rivals a tornado without ever spinning, why this particular storm system formed the way it did, and what the setup building over the next several days means for millions of people from the plains to the Appalachians to the East Coast. Stick with me through this one, because understanding exactly how these storms work is genuinely the difference between being caught off guard and knowing exactly what to do when the sky turns that unmistakable shade of green. Let's start with exactly what happened, because the scale of this event caught even seasoned meteorologists off guard. On the morning of August 11th, a cluster of thunderstorms fired up over eastern Iowa around 7 o'clock local time and almost immediately began organizing into what radar meteorologists call a bow echo, a curved boomerang-shaped line of storms that is the clearest visual signature severe weather forecasters look for when they suspect a derecho is forming. That system tracked east through northern Illinois and into northern Indiana over the following hours, and it did not weaken as it went, which is exactly what makes a derecho so different from an ordinary line of summer thunderstorms. A wind gust of 99 miles an hour was recorded at Gary-Chicago International Airport in Indiana, a number that puts this storm in the same range as a strong hurricane making landfall. The National Weather Service confirmed the system met the technical criteria for a derecho, and preliminary data showed the damaging wind track continued for at least 331 miles, stretching from Iowa through northwest Indiana and into Ohio, with meteorologists still assessing whether the storm's later push toward Cincinnati should be counted as part of the same continuous event. If it is, the total track could stretch past 600 miles. The human cost of that storm was immediate and tragic. A 4-year-old boy was killed in Geneva, Indiana, when a tree fell on his family's home during the height of the storm. In Ohio, flash flooding tied to the same system dumped as much as 8 inches of rain in a matter of hours across Perry County, flooding homes, vehicles, and roads around the towns of New Lexington, Somerset, Crooksville, and Junction City, and prompting emergency crews to conduct multiple water rescues. At least 6 tornadoes were confirmed embedded within the larger derecho, including 3 rated EF1 in Delaware County, Iowa, and 3 more in the Chicago area. A reminder that a derecho isn't simply straight-line wind. It's frequently an entire ecosystem of severe weather hazards moving together as one organized system. By midnight, more than 800,000 utility customers across Illinois, Indiana, Ohio, and Kentucky had lost power. And by Wednesday morning, that number had grown past 700,000 in ongoing outages as crews worked overnight, clearing roads buried under downed trees and tangled power lines. Indiana alone reported more than 300,000 customers without electricity after violent winds took down power poles across the state. In Illinois, homeowners in towns like Tinley Park spent the morning surveying roof damage and shattered windows, while in LaPorte County, Indiana, local officials described what they called a tremendous amount of tree damage stretching across the entire county. And utility crews from as far away as neighboring states were already being called in to help restore power, given the sheer scale of the affected area. Now here's a question worth sitting with for a moment, because it's the one people ask every single time one of these storms hits. What actually is a derecho? And why does meteorology reach for that specific word instead of just calling it a severe thunderstorm or a windstorm? The term itself comes from Spanish, meaning direct or straight ahead, chosen deliberately by the scientist who coined it back in the 1880s, specifically to contrast with the word tornado, which comes from a root meaning to turn or twist. That contrast is the whole story in a single word. A tornado is rotational, a tightly wound vortex that does its damage by spinning. A derecho is the opposite. It's a straight line of destructive wind, moving in essentially one direction across an enormous distance. And the official definition meteorologists use requires a continuous swath of wind damage, stretching at least 250 miles, with gusts reaching at least 58 miles an hour, sustained across most of that length. Some researchers studying these storms have recently proposed pushing that minimum distance out to 400 miles, based on newer analysis of how these systems actually behave, which tells you something important right there. Even the scientists who study derechos for a living are still refining exactly how to define them. because the storms themselves keep demonstrating just how extreme they can get. A recent multi-decade study looking back across 70 years of derecho data found that nearly half of all recorded derechos produced wind gusts stronger than 100 miles an hour somewhere along their track, which is a genuinely staggering statistic once you sit with it. That means the wind experience for someone standing directly in the path of a derecho isn't meaningfully different from standing in the eye wall of a hurricane, except it can arrive with far less warning and move through your specific location in a matter of minutes rather than hours. Understanding why a derecho behaves this way requires walking through the actual physics happening inside the storm, because this is genuinely one of the more elegant, if terrifying, processes in all of meteorology. It starts with three basic ingredients that every thunderstorm needs: moisture, instability, and some kind of trigger to get air rising in the first place. Moisture is essentially the fuel supply, humid air near the surface that thunderstorms consume to keep building bigger and taller. Instability describes how eager that warm, moist air is to keep rising once it starts, the same way a hot air balloon keeps climbing as long as the air inside it stays warmer than the air surrounding it. And the trigger is usually a boundary of some kind, a front, a pressure difference, or in the case of this particular Midwest event, a stationary boundary sitting between an intense summer heat dome to the south and slightly cooler air pushing in from the north. Exactly the kind of setup meteorologists have long identified as the classic derecho recipe. Once storms start forming along that boundary, individual thunderstorm cells begin producing rain, and as that rain falls, it drags cooler air down toward the surface with it, spreading outward in what meteorologists call a cold pool. Because cold, rain-soaked air is denser than the warm air around it, the cold pool acts almost like a wedge, plowing forward underneath the warm, humid air ahead of the storm and forcing it to rise rapidly, which triggers new thunderstorm development directly along the leading edge of the outflow. That process repeats itself over and over, storm after storm, regenerating along the advancing edge of cold air, which is the fundamental engine that lets a derecho sustain itself and keep traveling for hundreds of miles instead of collapsing the way an ordinary isolated thunderstorm does after 20 or 30 minutes. The specific radar signature that tells meteorologists they're looking at a derecho in progress is that bow echo shape we mentioned earlier. And understanding why it forms that particular curve is worth walking through, because it directly explains where the strongest winds end up concentrating. As the cold pool beneath the storm strengthens, it generates something called a rear-inflow jet, a fast-moving current of air that gets pulled in from behind the storm system and accelerates forward, essentially getting sucked into the developing cold pool and adding extra momentum to the whole system. That rear-inflow jet pushes hardest through the center of the storm line, where the system has had the most time and space to organize, which causes the middle portion of the line to physically outrun the flanks on either side. The result, when you look down at it on radar, is a line that bends forward in the middle exactly like an archer's bow, and it's precisely at that bulging center point where the absolute strongest, most damaging winds are typically found, sometimes in the form of an embedded rotating vortex that can spin up brief but genuinely dangerous tornadoes exactly like the ones confirmed during this week's Midwest event. That's part of why derechos are so uniquely dangerous compared to other summer storms. They're not delivering one burst of bad weather to one town before moving on. They're producing a continuously regenerating chain of destructive downbursts, tornado risk, and torrential rain that can hammer city after city along a single, relentless, hundreds of miles long track over the course of many hours. Before we get into what's actually coming next across the rest of the country, take a second and drop a comment letting me know if you were in the path of this storm, or if you've ever experienced a derecho before, because these events genuinely don't get the mainstream attention that tornadoes and hurricanes get, despite frequently producing comparable wind speeds and damage totals. I want to hear what it actually felt like from people who lived through it. And if breaking down exactly how dangerous weather systems like this actually work, using the real meteorology rather than just the headline numbers, is useful to you, go ahead and subscribe. Because based on what forecasters are already saying, this pattern is far from finished with the country. So here's what's actually coming next, and this is the part that genuinely deserves the word terrifying in the title, because meteorologists are not describing this as a one-and-done event that's already behind us. According to forecasters tracking the pattern, rounds of thunderstorms carrying the same damaging wind potential are expected to continue moving from the central and northern plains into the Midwest, the Appalachians, and eventually the Atlantic coast over the course of this week. The core concern driving this extended threat isn't just wind anymore, it's water. Because the same atmospheric pattern responsible for yesterday's derecho is expected to keep funneling repeated rounds of heavy rain over many of the same communities. Meteorologists are flagging a significant and growing risk of flash flooding in areas where storm after storm tracks over identical ground, a phenomenon called training, similar to individual boxcars of a train, all following the exact same section of track. When that happens, rainfall totals can climb dramatically, even without any single storm being exceptionally intense on its own, because the ground simply has no time to absorb one round of rain before the next one arrives. Forecasters have specifically warned that significant damage remains possible in communities where storms continue to intensify along this boundary, with the same kind of straight-line wind gusts capable of toppling trees and triggering regional power outages remaining a real threat as the pattern rolls eastward. It's also worth walking through the specific regional breakdown of where the greatest risk sits over the coming days, because a threat spread across this many states doesn't mean every location faces identical odds. Communities across the central and northern plains, still recovering from the initial round that produced this week's derecho, remain in the zone where renewed severe thunderstorm development is most likely as fresh disturbances continue riding along the same boundary that fueled Tuesday's storm. Moving east, the Midwest and Ohio Valley, the exact corridor already hit hardest by this week's event, face the compounding danger of additional heavy rainfall falling on ground that's already saturated and rivers that are already running high, meaning even a moderately intense round of storms could produce disproportionate flooding simply because the region has no capacity left to absorb more water. Further east, still, forecasters have specifically flagged the Appalachians as an area of concern, since mountainous terrain has a well-documented tendency to intensify flash flooding by funneling rainfall into narrow valleys and steep-sided creek beds that can rise with startling speed, a hazard pattern that has produced some of the deadliest flooding events in the eastern United States over the past decade. And, as the pattern eventually pushes toward the Atlantic coast later in the week, the primary concern shifts back toward damaging wind gusts and localized flash flooding in low-lying coastal and urban areas where storm drains and aging infrastructure in older cities can struggle to keep pace with intense, short-duration downpours, even when total rainfall amounts aren't historically extreme. This connects to something worth understanding about the broader, severe weather season this year because this event didn't emerge out of nowhere. It emerged from a pattern forecasters had already flagged as unusual months in advance. Long-range outlooks published earlier this year predicted that while the total number of tornadoes nationally would likely land closer to the historical average compared to the exceptionally active spring before it, the season would carry an elevated risk specifically for damaging straight-line winds, large hail, and flash flooding, hazards that don't always make headlines the way tornadoes do, but that spread destruction across a much wider area when they hit. Meteorologists pointed specifically to the transition away from a suppressing La Niña pattern as one of the key drivers, since that kind of shift tends to open the door for exactly the sort of volatile, moisture-rich, high-instability setups that produce derechos rather than the more classically tornado-favorable environments seen in stronger, more organized supercell outbreaks. Hotspots for large hail were specifically flagged, running from Texas up through Alabama, with another concentration expected across Iowa, northern Missouri, eastern Nebraska, and northeastern Kansas, a forecast that has proven accurate as the lower Great Lakes region in particular has seen a persistently dense cluster of severe weather reports building across the entire year. This week's derecho slots directly into that broader pattern rather than standing apart from it, which is exactly why forecasters aren't treating it as an isolated incident that's now safely in the rearview mirror. It's worth pausing here to explain why derechos specifically tend to cluster during these particular summer weeks, because the timing isn't random. These storms are most common across the United States during the late spring and summer months, generally peaking somewhere between May and July before tapering off, and they typically arise directly out of the kind of intense, sprawling heat waves that dominate headlines during the hottest stretches of the year. When a strong area of high pressure parks itself over a region for an extended period, it doesn't just bring clear skies and blistering heat, it also sets up exactly the kind of large-scale moisture transport. Warm, humid air riding around the edge of that high-pressure system and pushing into places like the Ohio Valley and Mid-Atlantic that provides the fuel derechos need. When that moist, unstable air eventually collides with a boundary separating it from cooler air pushing down from Canada, exactly the kind of setup meteorologists identified ahead of this week's storm, all the necessary ingredients come together at once. That's precisely the mechanism behind some of the most destructive derechos in recent American history, including the historic August 2020 Midwest derecho that tracked more than 700 miles from South Dakota through Iowa and into Indiana, producing wind gusts estimated as high as 140 miles an hour and causing more than $11 billion in damage, making it, at the time, the costliest thunderstorm event ever recorded in the United States. That comparison to the 2020 storm is genuinely worth sitting with for a moment, because meteorologists tracking this week's event have explicitly noted the parallels. The same combination of unstable warm air, abundant low-level moisture, and strong upper-level wind shear that produced the historic 2020 derecho was present again this week, And while forecasters have been careful to point out that this event wasn't an exact replay in terms of scale, they've also been direct in calling it recognizably the same playbook. That matters because the 2020 storm fundamentally changed how seriously emergency management agencies and the National Weather Service treat this specific category of severe weather. In the years since, wireless emergency alerts, the kind that trigger the loud emergency tone on your phone, even if you have notifications turned off, have been increasingly deployed for derecho-related severe thunderstorm warnings carrying destructive level wind threats, treating them with a level of urgency that used to be reserved almost exclusively for tornado warnings. That shift reflects a hard lesson learned directly from watching how much damage a fast-moving wall of straight-line wind can do to a region that wasn't adequately warned it was coming. It's worth understanding that not every derecho forms the exact same way, because meteorologists actually classify these storms into a few distinct categories based on the larger weather pattern they're embedded in. And knowing the difference helps explain why some derechos behave more predictably than others. The type behind this week's Midwest event is what's called a progressive derecho, the most common variety, which forms along a relatively short segment of a frontal boundary and then races forward largely independent of any strong upper-level storm system, essentially riding the heat and humidity ahead of it in a fairly straight, predictable line, similar to the historic 2020 Iowa event. A second category, called a serial derecho, is a very different animal, forming when a series of individual bow echoes develop along a single, much longer cold front tied to a powerful, well-organized area of low pressure, producing a broader swath of damage across multiple states simultaneously, rather than tracing one continuous narrow corridor. The historic storm of the century in March of 1993, which battered much of the southeastern United States with repeated waves of bow echoes over a single event, remains one of the textbook examples of that serial variety. There's also a third, rarer hybrid category that blends characteristics of both, and even a genuinely unusual subtype called a low dew point derecho, which develops in unusually dry air, generally during the shoulder seasons of late fall and early spring rather than the humid peak of summer, relying almost entirely on strong upper-level support rather than the deep tropical moisture that fuels a typical summer event. Nearly every documented derecho in the historical record forms in an environment with surface dew points at or above 70 degrees Fahrenheit. A genuinely muggy, tropical-feeling air mass, which tells you just how much raw atmospheric fuel these storms typically require to sustain themselves across hundreds of miles. Looking back through the historical record also helps put this week's event in proper context, because progressive summer derechos racing along the I-94 corridor through the upper Midwest are unfortunately nothing new to this specific region. Back in July of 1983, a storm that came to be nicknamed the I-94 derecho formed in eastern Montana and tracked essentially the same general corridor this week's storm followed, through North Dakota, into Minnesota, and across Wisconsin, with wind gusts reaching 100 miles an hour recorded at the Alexandria, Minnesota airport, strong enough to destroy hangars outright, before the storm eventually reached Minneapolis and cut power to 250,000 people. That event, more than 4 decades ago, was part of what first pushed meteorologists to formally study and name this specific category of windstorm as something meaningfully distinct from an ordinary severe thunderstorm outbreak. The pattern has repeated itself again and again in the decades since, almost always during the hottest, most humid stretch of the summer calendar, almost always along a similar east-west corridor, tracing the boundary between Canadian air to the north and a sweltering heat dome to the south, and almost always catching some percentage of the population off guard, specifically because the storm doesn't look, sound, or get treated with the same instinctive fear that a visible, rotating tornado does. Let's talk about what actually makes derecho wind so uniquely destructive compared to other severe weather, because understanding the mechanism changes how seriously people tend to take the warnings. A single ordinary severe thunderstorm might produce a corridor of damaging wind only a mile or two wide and a few miles long, essentially a localized burst that a community experiences for a few minutes before it passes. A derecho takes that same fundamental downburst mechanism and repeats it continuously, storm after storm, mile after mile, for hours on end. Which is why the damage swath from an event like this week's storm can end up tens of miles wide and hundreds of miles long, rather than being confined to a single town or county. And because the wind arrives as a wall rather than a rotating funnel, it tends to fell trees in a very specific, recognizable pattern, nearly all pointing the same direction, which is actually one of the tools damage survey teams use afterward to distinguish derecho and straight-line wind damage from tornado damage during their post-storm assessments. That consistent directional pattern is also exactly why derechos are so devastating to power infrastructure specifically. A tornado might snap a cluster of poles along a narrow, twisting path, But a derecho can lay down power lines and utility poles in a nearly continuous line stretching across an entire region, which is precisely why outage numbers from these events tend to climb into the hundreds of thousands, sometimes over 1 million, in a way that's rare even for moderately strong tornado outbreaks. This is also a good moment to address something that comes up constantly whenever a severe weather event like this makes national headlines: the instinct to ask whether storms like this are becoming more frequent or more intense than they used to be. The honest answer from atmospheric scientists is genuinely nuanced rather than a simple yes or no. Long-term historical records on derechos specifically are harder to maintain consistently than records for tornadoes, partly because formal tracking and classification of these events is a relatively newer science that has only been standardized in recent decades, which makes clean multi-century trend analysis difficult. What researchers can say with considerably more confidence is that the broader atmospheric ingredients favorable for these storms, namely higher atmospheric moisture content driven by warmer average temperatures, since warmer air is physically capable of holding more water vapor, are measurably increasing across large parts of the country. That doesn't guarantee more derechos in any given year, since the exact placement of fronts, heat domes, and upper-level wind patterns still varies enormously from summer to summer. But it does mean the fuel supply available for these storms, when the right ingredients do come together, has generally been trending toward more, not less, which is part of why meteorologists tend to treat each new severe weather season with a bit more caution than they might have a generation ago, rather than assuming historical averages alone will hold. Now, let's get genuinely practical, because understanding the science behind these storms only matters if it changes how you actually respond the next time a warning comes across your phone. When a severe thunderstorm warning is issued specifically flagging destructive winds, treat it with the same urgency you'd give a tornado warning, because the wind speeds involved are frequently in the same range, and the failure mode, being caught outside or in a vehicle when it hits, carries similarly serious risk. Get inside a sturdy building, away from windows, and if you're in a vehicle, get off the road and find solid shelter, rather than trying to outrun the storm, since these systems move fast enough that outrunning them is rarely realistic, and driving through falling trees and flying debris is its own serious hazard. Before severe weather season peaks in your specific region, it's worth doing the same basic preparation that applies to nearly any severe weather threat: trimming dead or overhanging tree limbs near your home, securing outdoor furniture and anything that could become airborne debris in high wind, and keeping a charged battery pack or backup power source on hand, given how frequently these storms knock out electricity across wide areas for days at a time rather than hours. If you live in a region currently under any kind of multi-day severe weather outlook, it's also worth having a plan for flash flooding specifically, since water remaining on roads after dark is one of the leading causes of storm-related deaths nationally. And the rule meteorologists repeat every single time for good reason is simple: never drive into standing water when you can't see how deep it actually is. It's also genuinely worth understanding how to interpret the risk categories forecasters actually use, since the language coming out of the Storm Prediction Center gets thrown around constantly during weeks like this without much explanation of what it actually means for your specific plans. The agency issues outlooks on a 5-level scale, running from marginal, meaning isolated severe storms are possible but not widespread, up through slight, enhanced, moderate, and finally high, the last of which is reserved almost exclusively for the most extreme, life-threatening setups, and is issued only a handful of times in any given year nationwide. An enhanced risk, the level that was placed over the Chicago area ahead of this week's derecho, specifically signals that forecasters have higher than normal confidence in numerous severe storms capable of significant damage, which is exactly the kind of designation that should prompt people to actually check the forecast again before heading out, rather than assuming a normal summer thunderstorm day. Watching how that outlook evolves in the days leading up to an event, typically starting as a broad, lower confidence area several days out and sharpening into a smaller, higher confidence zone as the event approaches, is genuinely one of the most useful tools available to anyone trying to track their own personal risk throughout a multi-day, severe weather setup like the one currently unfolding. Stepping back to look at the bigger picture, what this week's Midwest derecho really represents is a reminder that the most dangerous weather in this country doesn't always announce itself with the dramatic, funnel-shaped silhouette everyone immediately recognizes from a tornado. Sometimes it arrives as a wall of wind that most people wouldn't think to fear the way they fear a twister, moving in an almost deceptively straight, orderly line, right up until it's flattening trees, killing power to entire counties, and in the worst cases, taking lives. The atmospheric ingredients behind these storms, heat, humidity, and a collision of air masses along a boundary, are genuinely ordinary summer ingredients present somewhere in this country on any given July or August afternoon. What makes a derecho different is how efficiently those ordinary ingredients occasionally organize into something extraordinary, a storm system that behaves less like a single thunderstorm and more like a self-sustaining engine, feeding itself mile after mile until it's carved a scar hundreds of miles long across the map. And with forecasters already warning that the volatile pattern behind this week's event isn't finished, with more rounds of potentially damaging storms and serious flash flood risk expected to keep pushing eastward over the coming days, the smartest thing anyone in the path of this system can do is take the warnings seriously the first time, rather than waiting to see if this round turns out to be as bad as the last one. If this breakdown helped you understand exactly what happened and what's still coming, drop a like, because it genuinely helps this reach people currently in the path of this pattern who need to understand the actual risk, rather than just seeing another storm alert on their phone. Subscribe if you want to stay ahead of how this system develops over the coming days, because between the ongoing flood threat, the potential for additional rounds of severe weather, and the broader pattern driving this year's unusual severe weather season, the story is very likely not finished. And let me know in the comments where you're watching from and whether your area is currently under any kind of severe weather outlook, because tracking this together in real time, region by region, is genuinely one of the most useful things this kind of community can do during an active multi-day setup like this one. We'll keep following every update as the data comes in, every new severe thunderstorm watch, every flash flood warning, and every fresh outlook from the Storm Prediction Center as this pattern continues rolling east. Thanks for sticking with this one all the way through, and stay safe out there.